In this video, we're going to look at proof by induction and specifically for the matrices example. I do apologize, this question is a little bit blurry, but unfortunately I couldn't get a better quality. As always, we start by, I lost my words. We start by proving the initial case is true. To do that, you put n equals 1 into the right hand side of this expression and it should match the expression that's given in the question. So when you do put n equals 1 into it, what you'll see is that m to the power of 1, because remember n is still a power there, is equal to 2 to the power of 1, which is 2. This here becomes 0, this here becomes 1 because these are constants. And now 2 to the power of 1 plus 1, let's do this a little to the right hand side. Take away 2 is the same as 2 squared take away 2. 2 squared is 4 and 4 take away 2 is 2. So that will just end up as your expression here. Now we make the inductive statement. So now that is true for the initial case, we say assume for when n is equal to k, that this statement is also true, that m to the power of k is equal to 2 to the power of k, and then 2 to the power of k plus 1, all take away 2, and then 0 and 1 for the bottom row of the matrix. What we now want to show that is, actually, in a different color, I'm going to write what we want to show, because that does tend to help students a lot. We want to show that m to the power of k plus 1 is equal to everything here when you replace n with k plus 1. So instead of 2 to the power of n, we're going to have 2 to the power of k plus 1. Now here, when we make n equal to k plus 1, it'll be k plus 1 plus 1. So it'll be 2 to the power of k plus 2. All take away 2. And then this term here will be 1. So let's go about forming m to the power of k plus 1 and see if we can make it into this format that we want to show using the inductive statement. It's very important that you do use the inductive statement. So breaking m to the k plus 1 down, because of what we know about indices, it's the same as m multiplied by m to the power of k. So that means that we can take the matrix of m that's given to us earlier on in the question, and for m to the power of k, we can now use the inductive statement, which is a very important part of the whole inductive process. So let's do that. Minus 2, 0, and 1. And then let's now multiply matrices just like we know how to do it. So 2 multiplied by 2 to the power of k is 2 to the power of k plus 1. And you add on to that 2 multiplied by 0, which is nothing. 0 times 2 to the k is 0. 1 times 0 is 0, so that becomes 0. 2 times, okay, you have to be careful here because you're multiplying it to everything here. 2 times 2 to the power of k plus 1 is 2 to the power of k plus 2. 2 multiplied by minus 2 is minus 4. Oh, sorry. I just realized one little thing. Yeah, minus 4. And then we have, 0, sorry, I'll pause there for a minute. 1 multiplied by 1 is 1. Okay, it seems here that our expression doesn't match what we want to show. So let's have a little look about why that could be. So when I multiplied to get to this, I did the first row multiplied by the second column. When you do that, I multiplied 2 onto each individual term here. Oh, that's why. When you multiply, so let's say we're doing 2 multiplied by all of this. This is a very common mistake actually, so it's good that I made this mistake so that you guys can see it. You don't multiply 2 to each individual term. You only multiply 2 to one of the terms, because that's how multiplication works. So it's only the first term that we're going to multiply by 2 to get to 2 to the k plus 2. And we sort of leave this minus 2 as it is. And just like that, it matches what we want to show. Then you can make a little statement to say, hence, via proof by induction, this whole matrix here is shown to be true. One thing I did also miss out is mentioning k is greater than or equal to 1, because it was mentioned that like that for the start of the question for n, so we should always include it for k if there's a set domain mentioned in the start of the question. Be sure to leave a like if the video did help and subscribe. I'd appreciate a lot. Thanks for watching. Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-level further maths, be sure to hit my website up at www.excellineducation.co.uk.